So, you already know my name. You already know that I'm coming from Czech Republic. Like last year, I was one of the oldest studying PhD students. This year, I'm one of the youngest studying postdoc students at our institution, continuing inbreeding of the way of the thinking of the Bermen University of Technology. Anyway, I'm here to deliver you a presentation about paper with really awful title, Discovering Neighbor Devices in Network, and I really wanted to use also the second line, so over there I've put development of CDP and LLDP simulation modules for OMNeT++. This is the kind of ongoing effort that we are having at the Bermen University of Technology, where we are trying to extend the functionality of the INET and implement and integrate kind of the protocols and technologies that we know from our work with the Cisco Networking Academy. So basically a lot of the motivation behind our work is that basically we are trying to show students in a simulator what they are able to see in a real network and real devices. So let's hop onto it. The motivation behind this kind of the layer 2 discovery protocols is that they are priceless when it comes for the maintenance or for the troubleshooting of the network. Because they are working on layer 2, they can offer you vital information about devices that are directly connected with each other. So basically, if we will look onto the picture, and over there are, for instance, switch A, router A, they are periodically exchanging this kind of the messages that help them to discover neighbors in a sense that they will learn also about the features of these neighbors. Features such as, what is the IP address of my neighbor? What is the interface to which I am connected? What is my neighbor's interface? Which is really cool if there is, for instance, accident when, I don't know, angry squirrel will cut the link or a router will just shut down. You can use this kind of the protocols to detect that something bad happened, because you will lose your neighbor on the link, and since it's on layer 2, it's the lowest possible level where you can troubleshoot this kind of the neighborship and this kind of the problem. Anyway, this kind of the protocols, CDP and LLDP and also other ones, are also starting to play an important role in operation of, for instance, voice over IP infrastructure. Because usually the voice over IP phones that you are using on your table are communicating, for instance, with your switch, revealing their identity, telling the switch, I am the voice over IP phone, you should treat my traffic differently than the traffic of the computer, and so on. Also, they are getting very popular in data centers and other high availability networks when, for instance, LLDP is revealing other useful information like the position of the device within the rack or within the data center, which are the information that can be once again used during the maintenance or during the troubleshooting of computer networking problems. Basically, I've told you that they can exchange things like a host name, also things like the assigned IP addresses on the ports. These protocols can reveal you the software versions that the devices like routers and switches are using. And for instance, duplexness on the link, whether it is full duplex or the half duplex. And the theory behind them is quite short, I would say, because these protocols, only one thing what they are doing is that they are periodically generating a message containing all of this information. That's it. Nothing complicated, nothing request response, nothing like a request response scheme, just periodic generation of these messages. And as soon as you will lose the messages, you can determine, okay, my neighbor is down and something bad is happening. And at that time, you can use the things just like the command show CDP neighbor or whatever kind of the command that is available on your router or on your switch to check what kind of the neighbors are right now missing and to start troubleshoot the problem. This family of protocol is quite large. I've decided to implement only one that are important for me, which is Cisco Discovery Protocol, the first representative of this kind of the protocols, which operates over Ethernet on a dedicated MAC address depicted on the slide, and also Link Layer Discovery Protocol, abbreviated as LLDP, which is codified IEEE standard 802.1ab, And thanks to this codification by IEEE, this is the protocol that is usually used as multi-vendor solution when you have a mixture of, for instance, Cisco, Juniper, Hewlett-Packard devices. I can also tell you that there are many other representatives, such as Extreme Networks Discovery Protocol, Hewlett-Packard Network Discovery Protocol, Juniper Network Discovery Protocol. They are using the same kind of the feature, just the simple exchange of the messages in order to discover neighbors on layer 2. The messages are usually encoded using type length value scheme, which is really easy and really convenient when you are when you are extending the functionality of the protocol, because you do not need to create a new version, such as if we are having OSPF version 2 that it supports only IP version 4. At that time, when this IP version 4 is hard-coded into the protocol, so whenever we are switching to IP version 6, we need to use a new version of the protocol called OSPF version 3. On the other hand, CDP and LLDP are, by my opinion, properly designed protocols that are using this type length value or TLV scheme, which allows very flexible way how to add a new functionality in the form of new TLV. I will not go through all of the TLVs that are over there. Basically, they are revealing all kind of the information that I already mentioned. I will just show you, for instance, what is the Wireshark packet capture of the CDP, where we can see that it contains a lot of different type length value records, and each one of them is identified by unique identifier, revealing what is the syntax and what is the semantics between the value of this record. Yeah. I've already told you that we are extending original INET network. So what we are doing is that we are using the node base class that is, or node base kind of the node that is available in INET, and we are creating our own, let's say, OMNeT++ nodes that are incorporating or integrating all the functionality that we've already added. And in frame of this paper, we are interested in what is happening in network layer module, where we have added two submodules, CDP and LLDP. Each one of them designed using a similar pattern, where we have some main module, just like CDP main or LLDP main, which is responsible for exchanging CDP and LLDP messages. And for holding a state of these protocols, we are using kind of the neighbor tables or interface tables. In case of CDP, you can notice that there is additional module called ODR route table. And that is a very nice feature that Cisco offers for CDP, kind of the lightweight routing protocol, which is suitable for hub and spoke topologies, where we have some kind of the central hub, just a router, which is propagating default route and other routes to remaining spokes. So you can, in this kind of the use case, you can use actually the CDP to replace any kind of the routing protocol, because the topology is so, I would say, so simple, so easy, that even CDP will deliver you the same kind of the functionality as would RIP or OSPF. And that was also one of the major drivers behind our research, because we wanted to add another routing protocol into our protocol set, and that is this kind of the on-demand routing. How we've tested it? Basically, in a usual way that we will build simulation topology in OMNeT++, and we will also create a same topology using a real hardware. In our case, it was a real Cisco routers and switches. In case of routers, they were running the Cisco IOS version 15, same as the switch. And what we are doing next, that we are comparing the confluence of the messages and comparing the timestamps of CDP and LLDP that are being exchanged on the lines. In order to at least somehow categorize the measurements, we've decided that we will differentiate testing to two phases, the initial discovery and the interface restart. Regarding the initial discovery, you can imagine that right now we have freshly booted devices, and they start to exchange as one of the first things these CDP and LLDP messages. Both of these protocols offer something called fast start feature, which basically means that if I do not know any neighbor, I will send 3 subsequent CDP or LLDP messages in order to fasten the process of the neighbor discovery. Yeah, so over here on the table you can see the comparison between timestamps of CDP in the simulation and in the real network, where you can see they are somehow comparable if you will just kind of close your eyes. And the main reason is that usually for us it's really hard to perform this kind of the measurements between the real network and simulated networks, because usually simulated routers do not take into account things like hardware interrupts or the packet pacing or what else, or the things that are related basically with the hardware operation. Nevertheless, what we are usually trying to at least try to compare is the confluence of the messages, the order in what kind of the messages are being exchanged. And the same, it is, in this case, it is same for CDP, but it is a little bit different for the LLDP. And the reason is we can see over here some missing columns, or the field or the cell with the label missing, and that's the reason. The reason behind is that the Cisco LLDP implementation is not in compliance with LLDP standard, and it is not using this kind of the fast start feature. Hence, we've decided we will try to be as accurate as the standard is telling us, and that's the reason why, in case of the simulation, we are using this kind of the fast start feature. In the second phase, we've decided what will happen if we will flap the interface. This, basically only one use case that you can test when you are playing with the CDP and LLDP. So imagine that the link will go down at some time, and then the connection is re-established. And once again, you can see a similar order of messages being exchanged between, for instance, router R1 and router R2, which is kind of the confirming that we've at least implemented the CDP and LLDP according to the standard. So, to summarize my presentation, I've just introduced you a small code contribution that we've added to our ANSA INET package, where basically, in case of ANSA INET, we are extending the INET functionality with different layer 3 and layer 4 simulation modules. Last year, we've added also the support for high availability protocols such as HSRP and GLBP, both of them Cisco proprietary. And this year we are focused on, let's say, refactoring IP version 6 and refactoring IP version 6 dynamic routing that is available in INET by creating OSPF version 3. With this thing, if you are interested in our project, I will definitely, I'm glad to share with you the link. And once again, I must thank to the Rudolf that he offers us a placeholder under the omnetpp.org subdomain, which definitely helped us a lot to spread the word about our project. So this leads me to the end of the presentation. Thank you very much for the questions, for your attention. And if you have any questions, if you don't, I have my own question, because I will use what reviewers told me, because maybe for you it will be interesting to see what people that actually read my paper was thinking about the article itself. So if you will give me a few minutes, I will just go through the questions from the reviewers. They've decided, or they were concerned regarding, in case of the first question, whether I've considered also some background traffic. Yes, but in a sense that we are trying to compare what is comparable. Hence, in our cases and in our scenarios, we are trying to limit a functionality of, let's say, ANSA router and ANSA switch just for the CDP and LLDP, so we are not having any background noise when we are trying to compare it. Nevertheless, I would say that the outcome will be very similar. Are the LLDP packets missing in any test run or only in the worst case? In case of a real network, in all cases, because I've told you that LLDP implementation by the Cisco is not in compliance with the standard. The test was performed on a small scenario. Were there any further tests on the large scenarios? Yes. And since the protocol is quite simple, I wouldn't say that there are not that many scaling problems when using this protocol, because it's just you are sending periodically by default every 60 seconds one CDP or one LLDP message. And in addition, one reviewer mentioned, and I'm very glad for it, that LLDP is also used by other things like data center bridging extension and some quality control things. And maybe it will be another feature that we will add if we will find it interesting also for you guys. Maybe you will be glad to have this kind of the functionality in ANSA INET or in INET. And there are some concerns whether it is limited to ANSA INET. Yes, but to tell you the truth, my plan for the upcoming year is try to prepare some of our simulation modules to be integrated into INET, because I believe that it will help everyone if this is directly a part of the INET, and there's no reason to have it only in ANSA INET, where only major difference, by my opinion, is that we are using different kind of the configuration. So basically, if we are bootstrapping our simulation modules, we are using our own kind of the XML configuration because of the reasons that our use case is that we have a real device, we are using a special tool that will convert running configuration onto XML configuration that our simulation modules can consume. But I'm pretty sure that I can trim down the simulation modules to use the XML in some, let's say, lightweight form that it will be also available for any INET user. So that's my promise for you for the next year. You can check me next year whether I will at least deliver you a single simulation module. I just hope yes. Right now I will tell, of course. So, seriously, if you have any question, I'm one big ear.
Okay, so we can have a couple of questions, 5 minutes remaining. So, any question from the audience? Yes.
So it's more a comment than a question. I think the last part that the reviewer raised, that the models could be used like standalone or just available in INET, it's quite a valid thing, because I can definitely see applications for the Cisco protocol and the discovery protocols in other scenarios, like from the security and attacking point of view. I know that we have in our group certain people that are interested in modeling like attacks on scenarios where the router discovery protocols are attacked, or the service discovery protocols are attacked, and they would be glad to have those without the whole the whole everything needed, like INET and ANSA INET, everything needed, just the model itself.
Well, I take it as an advice why to continue this kind of the research,
definitely,
why to add this kind of the protocols to the INET set.
Okay, great. So, any further question? Maybe we can have one more.
Don't be shy.
But looks like you already
show me that you've actually paid some attention.
The question answers by yourself. So.
Yeah. I know that I'm usually pressuring.
Yeah.
So yeah, of course.
Yeah, so you can.
You are so interested that we can discuss it offline after the presentation.
So thank you so much. So to give the Vladimir one more big hand.